So I know this is in vertex form because it has the squared minus 1. So the first thing I'm going to do is decide if it goes up or down. Since that's positive, it's going up. The next thing I'm going to do is determine the vertex. Well, the vertex is the opposite of what's inside the x and the y. Sorry, it keeps doing that flashing thing. So then axis of symmetry is the x value of the vertex. X equals 3. So all of these are tied together. And then I have to go, okay, well, if it's going up, that means it's a minimum, and the minimum is at 3, -1, because that's the lowest point right there. Okay. I'm going to do the y-intercept next because I feel like it. The y-intercept is when you have 0, comma something. So I'm going to take the 0, and I'm going to plug it into that equation. So I'm going to go parentheses, 0 minus 3 squared minus 1. 0 minus 3 is -3. Squared is 9. Minus 1 is 8. Since you're going to get to use a calculator, you're going to have to show me this work and show me you didn't copy it off the calculator. So let me show you what I mean. So you're going to get a calculator, go to graph, and then sometimes you're going to have a graph there. So you're going to go menu, actions, delete all. Am I sure? Of course I'm sure. Okay. The next thing I want you to know is sometimes the range window won't be good. So if you go to menu, window, zoom standard, it'll make sure that it's right in the middle. Okay. And I'm going to now write the equation, parenthesis, x minus 3 squared minus 1. Okay, so I've got that. And then if I go menu, trace, graph trace, it gave me 0, 8, which is my y-intercept. So if you don't show me this work, I think you copied it off your calculator. Okay, so let's go down and let's see here. It told me my 0. Well, my 0 is at 2, 0. So I know the answer here is 2, 0. And it told me the vertex, 3, -1. And it should tell me that it's a minimum, but I don't know why it didn't. Maybe because it's so low. And I know the other one is 4, 0. Okay? So I filled in everything I need. Now I need to actually show that I didn't just copy it off the calculator. So how do I get the x-intercept? I set this equal to 0. So I'm going to go 0 equals x minus 3 squared minus 1. So I add 1 to both sides. 1 equals x minus 3 squared, square root, plus or minus 1 equals x minus 3. You need to show all your work? Heck yeah, I just showed you how to copy the answers off the calculator. You've got to show me that you did not copy it off the calculator. 3 plus 1, there's the 4, check. 3 minus 1, there's the 2. Now you're good on x-intercepts. Okay? All right, now let's zoom it out a little bit and let's do the table. Well, based on the table, you want the vertex to go in the middle. So the vertex is 3, -1. And this is a lot how your project is going to look, okay? Now, on your project, you're going to have to make sure that you include the y-intercept and or the x-intercepts, okay? So I'm going to include the x-intercepts, which actually ends up working out to me because I go less, and I'm going to go 0 here. Now, here's the deal. If this is 1 less, this is 1 more. If this is 2 less, this is 2 more. Now, 2, 0, 4, 0, 0, 8. So that one's got to be an 8. I actually didn't have to do any work on there, okay? So I want you to see I have my x-intercepts, important points, and I have my y-intercept in there. This is what your project's going to look like. Domain is all real numbers, -infinity to +infinity. Your range has to do with the vertex. So since it's going up like that, that means it's everything greater than. So y is greater than or equal to the y value of my vertex. And then since it's going up, bracket, -1, +infinity, parenthesis. Okay? My intervals, well, I'm going to graph it first, and then it'll be easier for me to do my intervals. So I need to do important points here. So we got a 0, that's important. 1, 2, 3, 4, 5, 6. So 2, 0, 4, 0, 3, -1. Better show that I'm okay. And then 0, 8, I'll fake it over here. And that means the 6, 8 has to match. Okay, make it look kind of like a U. I know it's not perfect, but make it look like a U. Don't forget to graph the axis of symmetry. You'll lose a point on the quiz and the test and your project if you forget it. So the intervals. So the intervals are negative infinity, positive infinity, positive infinity, positive infinity. Because when it's going to the left, that's negative, but it's up, positive. When it's going to the right, positive, it's also positive. And then my interval would be 3, -1. So if I'm focused on that, I'm saying negative infinity to 3. And it's going down, so decreasing. And then 3 to positive infinity. And it's going up, increasing. End behavior as x approaches negative infinity, f of x approaches. As x approaches positive infinity, f of x approaches. Since they're both going up, it's positive infinity, positive infinity. Okay, that's number 1. All right, number 2. Here, because it's negative, means it's going down. Here's my vertex. My axis of symmetry, it affects all that stuff. So -4, 6, x equals -4. It's going down. That means it's a max, and the max point is the vertex. To get the y-intercept, plug in 0. So I'm going to take that and plug in 0 right there. -2 times 0 plus 4 squared plus 6. 0 plus 4 is 4. Squared is 16. Times -2 is -32 plus 6. Oops, I put 0, 0. Is -26. Now, in a minute, when I graph it in the calculator, I'll check it to make sure we're good to go. Okay? X-intercept, make that 0. So 0 equals -2x plus 4 squared plus 6. This is going to be a workout. Actually, it's not that bad. -6 minus 6. -6 equals -2. X plus 4 squared. Let me zoom it in a little bit so you can see. Okay, divide by -2. 3 equals x plus 4 squared. Now, square root. I can't take the square root of 3. So it's plus or minus rad 3 equals x plus 4. So x equals -4 plus or minus 3. Oops. Now you can pick up your calculator and simplify it. Okay, -4 plus square root of 3. Round to the nearest hundredth is -227, 0. I'm going to look for this, though, because remember, you can just copy it. And then -4 minus the square root of, -4 minus the square root of 3, and I get -573, 0. Okay, so the zeros go in the y spot. All right, so before I even do anything, what I'm going to do is I'm going to pause it and graph it on the calculator to make sure I'm good. So if you look, there's my 0, -227. I can go down here to check my y-intercept. It's kind of far down there, isn't it? Oh, I went too far. -26, that's what I got, so I'm good to go. Now I'm going to graph it by putting my vertex in the middle. -4, 6. I want to make sure that I include my y-intercept and that I include my intercepts. So now I've got to figure out based on order what goes where. So that would be -227, 0, -573, 0. And then this one, I go 0, -26. Okay. And now I have to go, okay, well, the distance from here to here is 227. So now I'm going to go 227 minus 5, which is -7. Nope, wait. 6, -8. Okay, -26. So let me say it again. I figured out the distance from here to here is 227. So that means the distance from here to here is 227. So I just add that in my calculator and I get -8. All right. Domain, all real numbers, -infinity, positive infinity. The range is y is less than or equal to, because your graph is going to be going down, okay? Less than or equal to the y value of the vertex. Remember, when you do this, it has to be the smallest to the biggest, okay? End behavior as x approaches -infinity, f of x approaches. As x approaches positive infinity, f of x approaches. Since it's going down, it's it's negative infinity. I'll prove it to you by graphing. All right, so negative 4, 6, done. Negative 227 and negative 5.73 are here. And then negative 26 is here. And that means negative 8. I know, I kind of intersected this a little bit, sorry. Is there, I graph it like this, going down, show that it goes forever, do my axis of symmetry. This would be negative infinity, positive infinity, negative infinity. Because on the left side that's negative, it's down. On the right side it's positive, it's down. So now I'm going to do my intervals, negative 4, 6. So negative infinity to negative 4, it's going up. Negative 4 to positive infinity, it's going down. And I know that I'm good to go. See how that says when it's negative, it's negative. So when it's negative, it's negative. When it's positive, it's still negative. Okay. I'm going to do a next video on next problem when I do the next video.